First, you must know what is a randomized control trial. That is, in the randomized control trial, what you do is you allocate patients in a random fashion, and you also have a control group and the interventional group. So that is why it is called RCT, randomized control trial group, where you use two groups always to find out the efficacy of a treatment or the effect of a particular drug. So the steps what you have to do in designing and conducting the RCT are gathering the research team. The team members often include those with clinical expertise or experience in RCT method, statisticians, practitioners. All these things are needed. Then determining the research question. You must then decide what is the point that you are, what is the uh, research question you have to do using this acronym called PICOT, Patient Intervention, Control, Outcome and Timing, which is a crucial step which will guide to design the study. Then defining inclusion and exclusion criteria. This is the next step. You must know how to include the subjects that you are going to test. So restrictions are commonly applied to population eligible for recruitment. Inclusion and exclusion criteria should be carefully determined to strike a balance between generalizability and minimizing bias. Then comes the randomization, where allocation of patients to study group by chance. And then intended function of randomization is to balance known and unknown confounding factors between intervention and control groups, thus minimizing the impact and relationship between the intervention and the outcomes. And also it reduces the bias that is likely to happen. Then the next step is determining and delivering intervention. In RCTs, it is important to ensure that intervention is specifically defined and consistently delivered. Then selecting the control. Control group is selected by additional exposure offered by the intervention. Then first consider whether to use a placebo control or an active control. This is also another important point that you have to determine. Then determining and measuring outcomes. Although trials generally identify primary outcome from which sample size needed to detect outcome at a statistically significant magnitude is calculated, secondary outcomes also sometimes happen, which can be considered if they are likely to be influenced by the intervention. And all relevant outcomes should be identified a priori. That is, before the study begins itself, you should be able to have a idea about what outcome do you expect from this particular testing. For example, if you are doing a study on antihypertensive on two groups of patients, you expect the systolic blood pressure to come down or the diastolic blood pressure to come down depending upon the pharmacological nature of the drug. So you should have that outcome in your mind and see whether what you expect is happening. So that is called the measuring the outcome. And outcome measurement should be standardized as possible. So the drafting of semi-specific definitions can sometimes be used. Then blinding participant and investigators. This is a very important part of the sometimes randomized. So this is also asked as a short note question. Single blinded, double blinded and triple blinded RCTs. So to minimize opportunities for bias, some form of blinding is often employed. So there are three groups of individuals who are involved whenever you do a RCT. One is the patient, second is the investigator, then the third is the study team. Now, if the patient alone does not know which group he belongs to, it becomes single blinded study, because he is not going to be aware which group he will be allotted. While the double and triple blinding means the patient does not know, the investigator does not know in double blinding, but the study team may know. Whereas in the triple binding method, all the three people are not aware of what is the drug being investigated, which patient is coming to you. Then ethical considerations in RCT are information provided to the patient as part of the informed consent process must be very clearly given to the patient. So patient should be able to made to understand why that study is being done and what is its role in the study. Then you collect the data and then patients group allocation, and then interpret with the investigator or bias reporting by the patient if individually their feedback or quality care is provided. Then determining sample size and analyzing the data is also important. So sample sizes are estimated on the basis of the expected effect of intervention versus the control on the primary outcome. Now disseminating and reporting results, that is the final part. Dissemination of study results may take the form of poster or oral presentation at an academic or professional conferences, and publication in a peer-reviewed journal or discussion in the network and communication will be done. So these are all the various steps by which you can write this answer of a randomized controlled trial, where I think most of the points will be included if you write this in this fashion instead of trying to write about individually how to do that. Okay, and this is the design of randomized controlled trials, where you do the study population, study sample, application of inclusion exclusion criteria, then randomization, intervention group, control group. Intervention, what do you do, what is the outcome in these groups. This is over a period of time. This is how the simple randomization is done. Now, what are the strengths and limitations of randomized controlled trial? The strength is it is able to evaluate causal relationship. Limitations, higher cost than observational studies, and high internal validity, limited external validity and generalization. And the strength is investigators control over patient exposure. Ethical considerations related to assigning patients to particular care approach takes limits your level of intervention. Prospective data collection, which allows for standardization here, that's the strength. There are generally shorter duration follow-up than observational studies. And attempted balance through randomization is very good in this, is one of the strengths of the RCT, whereas inefficiency of detection of rare or delayed outcomes are smaller, because you can't do a long-term observation or follow-up with the RCT. It is always a short-term, smaller trial. So you have to close it, whereas the other observational studies, you can ask the patient to come even for follow-up after 6 months, 1 year or 2 years also, and publish your reports. So that is about the, if this question is asked as a ASCII question, then I thought these are all the questions that are asked in the normally. What is shown here is the, it is a flow chart showing the 4 phases of controlled trial using 2 groups. So first assess the eligibility, then randomize, allocation to intervention, allocated to intervention, receive intervention, then this is the 4 steps: enrollment, allocation, follow-up and analysis. So this, in one of the ASCII questions, I found this flow chart being given, and then the questions were asked. And what is randomized controlled trial? RCT is a quantitative, comparative, controlled evidence in the investigations to study 2 or more interventions in a series of patients who receive them in a random order. That is the most important. So there is always a control group and an interventional group, and the patients are allotted in a random fashion. Why randomized study is considered ideal? Because difference outcome is directly attributed to difference in treatment and not due to other facts. What are the basic steps in conducting RCT? Draw protocol, select reference and experimental population, randomization, manipulation of events, follow-up, assessment of outcome. Why blinding is done? Mention and explain the types of blinding. Errors in assessment in RCT can lead to bias. So 3 sources of bias are subject variation, observer bias, evaluation bias. So randomization cannot guard against these bias, so blinding is done. And blinding can be single blind when participant is not aware which group he belongs to. Double blind, participant and investigator are not aware, and triple blind, participant, investigator and analyzer are not aware. Okay, so these are all the question answers for OSCE. Now coming to data, what is data? Data are measurement or observations that are collected as a source of information. And it's a collection of facts and figures which can be used for a specific purpose such as survey or analysis. Now the types of data can be qualitative or quantitative. Qualitative data, they represent some characteristics, attributes, and they depict description that may be observed but cannot be computed or calculated. So it is like the quality of a person, like honesty or your hair color or your eye color, like that. It is a quality that experience. Examples attributable are intelligence, honesty, wisdom, cleanliness, eye color, hair color, creativity, etc. Whereas quantitative, as its number says, it is a measured and not simply observed. They can be numerically represented and calculations can be performed on them. So there is numbers involved in that. And examples are the patient's height, age, weight, etc. So the types of data you can describe them into qualitative and quantitative. So qualitative, like examples are names, color, smell. Quantitative, shoe size, height of student, weight of students. So this way you can remember that difference. Data collection is the way you collect it. Depends on primary data or secondary data. So primary data is original information that has been collected for a specific purpose. And it is a pure and raw form of data that has never been processed. And it is organized in such structured way for future use. And primary data can be qualitative or quantitative and cannot be derived from another source. So this is the first time collection of data. An example of primary data is the census which you take. Supposing you try to assess how much of the population is there in an area and you collect all the details, that census becomes the primary data. But after collecting that, if you want to find out how many religious people are there, which religion is more dominant, then it becomes a secondary data. So secondary data is sourced from an existing data source, either in an unpublished or published form. It is any data that has already been collected or is available for use by researchers. And examples of data are information in government statistics, journals, etc. Now, types of data and statistics, again, I told you qualitative and quantitative. Qualitative is non-numerical. There is no number in that and it is categorized. Like example of hair color, other characteristics. And quantitative data is numerical, objective data that can be measured and compared. It can be the height or weight, as I told earlier, and it can be subdivided into qualitative data, subdivided into nominal data. The data which includes names and labels. Examples of nominal data include nationality, religion, etc. Ordinal data comes in an order, the serial number. So ordinal data are data which labels indicate ranking or order. So in our specialty, we can say the pain score, ASA grade, they are all ordered because you can say ASA 1, ASA 2, ASA 3, 4 like that. And pain score you can say 1 to 10. So all that comes in an orderly form of numbers. So that is called ordinal data. Whereas numerical and quantity data, there is a discrete data which is countable, meaning that it can be broken down into individual units. Discrete data is usually collected through surveys and experiments, and it can be representing using graphs. One advantage of discrete data is that it is easy to understand and interpret. But the disadvantage is this obtained results if the sample size is small, you can have uh, difficult to obtain accurate results and can only be limited to small variables. The continuous data is a type of data which can take on any value with even decibels. So for example, if you say discrete data, if you say how many kids you have, you can say only 3 kids if in discrete data. And you cannot say you can have 3.2 kids. Whereas in continuous data, you can say you will have a temperature of 37.8 or a height of 150.4. So decimals can be included in continuous data in a wide range, and it provides more information and used to make accurate predictions. So the main difference, discrete data may be sometimes inaccurate, whereas continuous data is quite accurate. And there is another thing called interval data, which is also called an integer. The defined as a type of data which is measured along a scale in which each point is placed at equal distance from one another. So it shows the interval. For example, visual analog score or scale, which you have 1 to 10, you have a definitive point. So depending upon, if the patient says 9 out of 10, he is in extreme pain. Whereas if he is in 2 out of 10, he is in very mild pain. So like that, you can easily find out the data. And interval data appears in the form of numbers or numerical values where distance between the 2 points is equal and standardized. Then there is a ratio data where it's a definitive quantitative data having some properties as an interval, same properties as interval data with an equal and definitive ratio between each data, and an absolute zero being treated as a point of origin. So there can be no negative numerical value in ratio data. That is a very important difference between ratio. For example, in interval data, you can say the temperature is minus 4 degrees centigrade, at which you have to keep your um, the infusion fluid for the preservation fluid in the kidney transplant. Whereas that cannot be done here, but you can compare the two values between the interval data, which are always positive. So that is the main difference between interval data and ratio data. Okay, so I think that's all what you have to say with regard to, and that completes that discussion on all the 5 topics that we have today.